Hello everyone, so today our topic is about wave effects. Okay, so here let's move into our first slides. And here's a video, but today's time is limited, so we haven't got time to watch it. But I have a brief introduction about the video. Okay, so here's a phenomenon in our daily life about reflection, refraction, and diffraction. Like here you can find, like if you are watching a mirror, you can see yourself, right? And this means that your body has light and then reflected into your eyes, right? So here we can say this is a reflection. And what about refraction? And if you put a straw in like a bottle, you can find in the glasses. Here is a straw just have like just chop off like this way. Okay. And for diffraction, maybe if you have a light and then going through a very small gap, they will find some like patterns on the floor. Okay. So we can using these three effects to like making some conclusion of this. Okay. Let's move into the first part of the reflection, okay? So reflection, like here, is like a wave and just moving from the left to the right, okay? And then maybe it hits on a wall or like hits on other, like maybe mirror or other thing, okay? And then it just rebounds like this way, okay? Rebounds like this way, okay? So you can find this wave is, or every wavefront is like a plane wave, right? It's like a plane wave. So once they rebounds, they also have still a plane wave, right? And also you can find here, it's just like a ping pong ball that just hit on the wall and then reflect or rebounds like this way, okay? And here we can make some conclusion for this. First of all, you can find the wavelengths are the same for the initial wave and the rebound wave, right? So we can say that they have the same wavelengths, okay? And also you can find right here, they just have a same angle for reflected, right? Like if you're letting this as a perpendicular line, we can call this normal, okay? And here is the angle between the incidence wave and the reflected wave, they have the same angle. So we can say here that the incidence equals to reflected. Okay, so here is a basic knowledge for reflection. I think it's very easy for you, right? And maybe next we are talking about refraction. So what is refraction? We can say refraction is just like an athlete and he's trying to making some exercise. And once he just like running on the ground and once the environment changes, like here we have the maybe wave from the air to the glass, okay? That means he had to change his like posture and he has to change his like running like position and trying to make him running direction a little bit changing, okay? And that can make him less restriction, okay? So it will first change its direction, and once the wave just moving out of the glasses, that means that it's still in the air, right? Or it's back to the air, right? So it moving direction just comes to the original place, okay? So you can find here that refraction just means a wave or like we have make an example that oscillators running in different environment. So here it's just like the sound, like the waves just moving in different media, okay? So reflection happens when the wave traveling in different media, okay? Traveling in different media. This is the first when the refraction will happen, okay? And secondly, we can find here that you can find in the air, maybe the distance between every or the closely the wavefronts that is very long. And here it may be shorter, like here, right? So we can say that the wavelengths will change in refraction, okay? So here is a second property we have found, okay? And maybe here we can also find that the wave traveling direction the same as it is in the same, like maybe in the air or like here, right here in the air and here is the air, okay? Same direction after maybe after applying mirror, okay, like this way. Okay, so here is for the refraction, okay. And maybe here we can just have some phenomena in our daily life. We have said that like a straw or like a chopsticks just cut off by different medium, like this way, okay? So the last part of the wave effect is diffraction, okay? And what is diffraction? And you can find here that the wave just traveling through the gap and have different ripples like here, okay? And maybe we can say that before the gap, it is a plane wave, and after the gap, it is like a curveless plane wave, right? So here we can say that the diffraction means that wave traveling through a gap and maybe become more curveless, right? Like wave traveling through the gap means that the curveless or becomes more curved, okay, like this way. So maybe here we have some questions. So why here you can find the first figure and the figure on the right, they have a different phenomenon right here. So maybe we can explain that for diffraction, you can find from the left to the right, maybe here you can find the gap is smaller than the right gap, right? And the wavelength here is the same as the right wavelength, right? So maybe you can just imagine the wave as a person, maybe it's a person who is very like a little bit slimmer or a person who is a little bit heavyweight like this way, okay? So maybe if a person who is a very heavyweight, or that means that the wavelength is very big. Maybe heavyweight means you have a very big y, right? So here the y is just equals to the wavelength, okay? So wavelength increase, that means that is for the person it's very hard to go through the door. Maybe he wants to pass through it and his body will change like becomes unshaped, right? And maybe before he is a very straight body, and after he passes through the door, he has to put his belly into his body, right? And trying to make the door or trying to make through going through the door, right? So we can say that maybe after going through the door, his body unshaped or has to become another shape, right? So that means the curvature increase. Okay, and we can also say that if the gap is very small, that also will make the curvature increase, right? Because the gap wise means just like the doors wise, right? So it will also make the curveness increases. This is for diffraction. So maybe we can have a conclusion for this. We can just imagine the wave and the door, wave and the the gap just as the person who is slimmer or who has a heavy weight or just like a door. Okay, so here is for diffraction. You can just remember this. So here is a very important property. So using this way, we can just try to draw the diagram. Please remember that here, the wavelength on the left equals to the wavelength on the right, okay? They have the same wavelength. And in our P4 test, sometimes we have to draw like 2 or more wavefronts after the gap, okay? This is a request in our test, okay? And secondly, you have to remember that we have already using a view of like particles view, right? We are just imagining the person as a wave as a person, just like a particle just passing through the door. We have another explanation for diffraction, that they can go through the barriers or the wavelengths can travel in another direction, another different way. Like here is a barrier for a wave to traveling. That diffraction also means that it can just going through or just jump up and then traveling on the barrier, okay, like this way. So we can also think that diffraction also has a property of waves, okay. So maybe in the future, when you go into the university, when you're learning about undergraduate, you learn about the wave and particle duality, okay. That is the future knowledge that you learn. Okay, so here is a two explanation. You can just take a note for this. I think it's very important for you to understand diffraction. Okay, so that's maybe like having access here, like trying to explain how the wave will change its shape, like there in the picture. Okay, try to solve the problem, please. Okay, I think you got the answer, right? So here you can find a wave just traveling through a gap, right? And it a question is what happens to a rainbow pattern to the right of the barrier, right? So you can find here, maybe here the gap size increase, like so gap size increase just means like the door become more wide, right? So we can say that the people going through the door becomes easier. So maybe his shape doesn't change anymore, right? Just going through very easily. So maybe we can say that here the ripple are less curve, right? So we are choosing D. And remember that the ripples are closer together, that means their wavelengths, right? We have already talked before that wavelengths before the gap and after the gap are the same, right? So D doesn't change. So A, B is correct. Okay. So finally we choose D. Okay. So here's today's our lesson. I think you can have a better understanding for diffraction, reflection, and refraction. Okay. And we will learn another time when we learn about light arrays. Okay. So this is today's our lesson. Okay. See you next time. Bye.